Hello and welcome back to Ganesh Institute. So in today's video, we are taking up another test to check reducibility or irreducibility for a particular polynomial. Let's say we have one polynomial fx which is x cube x square plus 2, and we need to check whether it is reducible or irreducible. That is, it can be factorized or not over Z3. Now when we say Z3, that means Z modulo 3, okay? And when it is modulo, you need to consider the number of elements up to n minus 1. So this is modulo n, you can consider it up to n minus 1. So there are 3 elements for which we have to check whether this is reducible or not. So one by one, just put down all these values in fx and find out the mod 3 value for it. So firstly, f0. If we put 0, here 0, 0, it is 2. So 2 modulo 3. You know very well that what we have to do in order to solve this. We have to take this as divisor and this as dividend. Okay. This as divisor, this as dividend, and you can see it cannot be divided further. So 2 is, because it is less than the divisor, so it becomes the remainder itself. So we can write it as 2 only. Okay, so f0 is 2. Now because it is not coming out as 0, that is, it is not completely divisible, that's why we cannot say that it is reducible for 0. Now when we substitute the value of 1 here, we can see 1 cube is 1, 1 square is 1, so 2 and 2, 4. Now 4 modulo 3, this is called mod p test. So we are checking whether we are getting, if we are taking up modulo p, that is a particular prime number, and we are getting 0 or not as remainder, as the answer. So if answer is 0, then we can say reducible, and if not, then irreducible. So just divide this. So this is divisor, this is dividend. 3 ones are 3. What is the remainder? 1. But 1 is not equal to 0. That is, this is not divisible completely. So we will say that it is not reducible for f1 as well. I mean, the value of x1 is also not satisfying it for the reducibility. Now what is next? Similarly, you can see the f2. Now for f2, you can place the value 2. 2 cube is 8, then 2 square is 4, then 2. 8 and 4, 12, and 2, 14. So 14 modulo 3. Now again, if you divide this, 3 4s are 12, so you can see 2 is the remainder. So this is 2 modulo 3, right, which is again not equal to 0. So that's why we can say that for any of the roots, no roots are lying in Z3, and hence there are no factors, and this polynomial is irreducible. So this is how you can apply mod p test apart from the Eisenstein's test, which I have already discussed. So in order to check the irreducibility, you can use mod p test. Okay, this is it from my side for today. Till my next video, take care of yourself and don't forget to like, share and subscribe my channel. Bye bye.